Okay? So the topic today is unintended consequences of security lockdowns. And I should point out, my name is Aaron Margosis. I'm a principal consultant with Microsoft Services. I work in the federal area. I work primarily with US federal government customers. I spend a lot of time on security policies. I interact with National Institute for Standards and Technology, NIST, and NSA, and DoD, and others to formulate security guidance, and as well as the Microsoft Security Solutions team as well. So the big takeaways here are to understand the trade-offs between some of the settings you might have, or you might look at, and to diagnose some problems that sometimes come around from security lockdowns. And the big key takeaway, they changed the formatting. This was supposed to be, this is supposed to be in big font. Tightening a security setting doesn't always lead to better security. Okay, just because it looks like a good idea doesn't necessarily mean that it's going to have the impact you think it will. So I'll give you a brief history of some of the security guidance that's out there, both ours and third parties. And then we'll look at a bunch of different security settings and some of the adverse impacts they can have. Okay, so some release dates. Windows NT 4 released in the year 6 BTC, and Windows 2000 in the year 3 BTC, where BTC is before trustworthy computing. Trustworthy computing memo, Bill Gates, 2002, said, okay, backward compatibility is good, but our customers demand security as well. We need to turn things around and make that the top priority. So, Windows was very popular in government and elsewhere, of course, and people were using Windows. But was the security as good as it needed to be? Was the default security as good as it should have been? And quite frankly, the answer is no. It wasn't good enough. And that's why the US National Security Agency and others stepped in and said, if you want to run Windows, you need to secure it first. You need to lock some things down. And they put out a lot of security guidance about how to configure the system. One of the things they did a lot was change all the security permissions, all the access control throughout the file system in the registry, primarily to get rid of, I think, everyone, permissions granting access to everyone and power users. Nowadays, we have something better for getting rid of power users, and that's restricted groups. You can just say no one's in the power users group. Power users, by the way, is admin equivalent. There's enough control that power users have on XP and earlier, and 2003 and earlier, to easily take over full control of the system. Jesper Johansson wrote in a post one time, power users are simply administrators who haven't added themselves to the administrators group yet. So Windows 2003, Windows Server 2003, year one of the TWC era, the operating system was delayed by a year because of security, to lock things down, to review and refresh everything, and to instill the idea of security within all the developers and testers and everybody, program planners, everybody within the product group. And another thing we did is we came out with the security guidance up front, and we worked with the NSA and other security stakeholders to come up with what we felt was something that we could all agree on. And so when we published the guidance, and we released Windows Server 2003, the NSA's security guidance said, do what they said. And they pointed, actually, we had two security scenarios, enterprise client or I guess not enterprise client, but enterprise and high security. And of course, everyone says, well, I need high security, of course. Right? Well, the idea behind the high security was it was really going to lock some stuff down. So around that time, we renamed it to Specialized Security Limited Functionality, SSLF. So that's what used to be high security. And it makes it clearer that if you apply these settings, some stuff won't work. So you have to give up some functionality to get there. And NSA said, if you're deploying this, you should use the SSLF guidance. Windows XP Service Pack 2 was kind of equivalent in terms of security. That was the first time we released something that we knew was going to break some things in the name of security. And the problem was that NSA's security guidance for Windows XP came out around the time Windows XP came out, and they didn't update it. And so a lot of people were still applying security guidance that swept through the file system and the registry, changing the permissions everywhere. And we kept seeing things break. And I was actually working at a particular government customer, and they said, hey, you know what, look at this. If I delete this file, and it says, do you want to move it to the recycle bin? I say yes. I look in the recycle bin, it's not there. I said, that's weird. It's not supposed to work like that. And I dug into it and found out it was because of the security permissions that the NSA's guidance was pushing through group policy, was making everything pretty much admin's full control, users read-only. It made the recycle bin writable only by administrators. So users could no longer delete into the recycle bin, but administrators who deleted stuff to the recycle bin made their stuff readable by all users on the computer. That's an unintended consequence of a security lockdown. NSA said, oops, unintended or accidental oversight was the phrase they used. And from that, we started working more closely with them to come up with security guidance across the board. So yeah, two things came out of that. One is KB Article 885409, which basically says don't make big changes to the security. Default security is fine the way it is. And you can cause serious problems on your system if you mess with those too much. And then the consensus settings, like I said, we worked with NSA, and we came out with guidance that applied to everybody. They stopped recommending sweeping ACL changes throughout the system. So in the federal government space, there's a lot of different security guidance. In the DoD, you have the Security Technical Implementation Guides, the STIGs. You can't deploy anything to a DoD system unless there's a STIG saying, here's how you do it. Around 2002, 2003, the US Air Force decided to take much better control over all their systems, which was a big undertaking because they're worldwide pretty much. Not everywhere, not yet. They came up with a standard desktop configuration, which was based on Windows XP Service Pack 2 and a common security configuration for all those systems, and above all users had to run as standard user. It was a huge undertaking, getting all these disparate systems. They had Windows 98 running places and different versions of NT. But they got this done, and the security savings, just the impact of security problems was much, much lower. The cost of maintaining the network was much, much lower. And as a result, the US government's Office of Management and Budget took a look at that and said, we need to do the same thing throughout the federal government. And they came out with the Federal Desktop Core Configuration, FDCC, which is a very similar set of settings, and it demanded all end users run as standard user, and a set of security guidance saying, these are the settings you need to apply. And so they came out with guidance both for XP and Vista, and then by the time Windows 7 shipped, it was a new group of people, and they said we have to put our own name on it, and they renamed it to the US Government Configuration Baseline. You can get to these through usgcb.nist.gov and fdcc.nist.gov. So now anyway, it's all USGCB. FDCC is now just a 4-letter word beginning with F. And of course, we have the Microsoft Security Guidance, which is now encapsulated in the Security Compliance Manager. Has anybody seen the SCM yet? Anybody working with it? There's at least one session here that will cover that, and I have them listed in the deck near the end. This will, if you're doing any kind of security management, security policy management, you want to take a look at this. It's going to make your job a whole lot easier. Okay, so let's talk about some settings. One of the settings that's been in there for a long time, and it's been recommended through Microsoft guidance, and it was demanded by the DoD STIGs, FDCC, and USGCB, was the user right assignment debug programs, which by default is granted to administrators, was not to be granted to anybody. Take it away from administrators. Don't give them that power. So what does that privilege do? It's a privilege that allows the user who has that privilege to take full control over any process on the box. Okay, with the idea that you might attach a debugger, but you can also peer into it, see any part of memory, as long as you have that privilege. Oh, and you can modify what the program does, too. You can take full control over it, even if it's running as a different user. you don't need this privilege to write code or debug code unless you're debugging something that's running in a different security context. If you're writing desktop software, Windows Forms, VB6 even, you don't need the debug program's privilege for that. It's your process. You have full control over it. It's only if you're taking control of something running in a different security context. For example, you're debugging a service. Then you will need the debug privilege. Diagnostic and troubleshooting tools use this so they can tell you what's going on in the system. This is an admin equivalent privilege. Obviously, if you can take control of something running as local system and make it do whatever you want, you're admin on the box. So you should never grant this to non-administrators. So the thinking behind revoking this from administrators was it is supposed to prevent an attacker who has an admin account or has control of an admin account from taking over sensitive processes like LSAS, Local Security Authority Subsystem. The actual benefit is none. And the reason is it's completely trivial to bypass. If you're running as admin, there's nothing anybody can do to stop you from doing anything. The big drawbacks of applying this setting are it breaks legitimate developer scenarios, it breaks legitimate IT pro, IT management operations, and for some reason, SQL Server and SQL Express, the installation programs require the debug privilege. I'm not sure why. So you'll have trouble installing those if you've removed debug from administrators. So I said it's trivial to bypass. Why is that? Well, if you're running as administrator, there's a few things you're already allowed to do. One is you can configure services. You can configure anything to run as local system, which always has the debug program's privilege. So from there, you can do anything you want. Okay, a couple different ways of doing that. You can use sc.exe. You can use psexec, the sysinternals utility. You can run things as local system with that. Another thing administrators can always do is to take ownership of an object. You have ownership of the object, you can change the permissions on the object. So there's a process that you don't have direct access to without the debug program's privilege. You can take ownership of it, change the permissions, they grant you access, now you're in. So trivial to bypass. So an attacker who knows that he's attacking a system where he doesn't have debug will know how to get around that. The bottom line is trying to restrict what admins can do on a box is futile. If you've gained admin, there's security by obscurity, and that's about all that there's going to be left. And the good news, I showed the demo I'm about to show you I showed it to NSA and DoD and others, and they agreed that setting doesn't make any sense. We're going to take it out. And so Microsoft security guidance no longer includes that, and the USGCB does no longer include it. Does anybody here work with the US federal government as a contractor or employee? Okay. How many of you, let me ask this, how many of you apply security guidance like the Microsoft security guidance on your systems? Okay, not a lot. So do most of you just use the default security? How many of you use the default security on the system and just leave it at that? What do the rest of you do? Just pick and choose what looks good? Is that what you do? Just a gold disk. Okay, that's based on security guidance. Like it's a prescriptive guidance. How many of you, I should ask this, how many of you use prescriptive guidance either from Microsoft or the DoD or USGCB or something like that? Okay, a bit more. Okay, that's good. I actually have a blog post, and I'll show you the link a little bit later, describing why it's important to go with prescriptive guidance rather than making it up. Okay, so let's have a demo. And I'll switch glasses because bifocals aren't enough. Okay, so here I am. I'm an administrator on this Windows 7 system. I'm going to start Task Manager. I can see the processes running as me. I'm going to run this thing with full administrative rights so I can see all processes on the box. And I see there's things running as Abby. I'm running as the user Abby. There's some services running. And then there's some where I don't see the username. And let's see, there's a notepad here and a calc. But I can't see who's running them. Well, what's up with that? Can I kill that process? End process, do you want to? Yes. Access denied. I'm running with full admin rights, but without the debug privilege, I can't kill this process. I can't tell much about it. Well, problem here is I'm running Task Manager. How about if I use Process Explorer instead? How many of you are familiar with Process Explorer? Good, okay. Here's a little tip, Process Explorer. Now, everything you run on Windows, assuming you still have UAC enabled, which you should, everything runs as standard user unless you say elevate this thing. Process Explorer takes /E. You add a /E to the command line, and it says run it with admin rights. OK, so here we go. Let's see. There's that notepad. There's calc. Now, I should be able to hover over these and see the path and the command line to these processes, but it's not showing me anything. And on the username column, access denied. Double click, no information here at all. I don't know if this is the real notepad or not. No information, no information. Security, who it's running as, security groups, nothing. It's because I'm missing the debug program's privilege. Can I kill that process? Delete. Access denied. OK, but I'm running as administrator. Let me fire up an admin command prompt and then run psexec. How many of you are familiar with psexec? It's another sysinternals tool. Let me point something out here first real quick. I have a book coming out. Let me point out an important feature here. Windows Sysinternals Administrators Reference by Mark Rusinovich and Aaron Margosis. That shows the division of labor that was involved in the writing of the book. I wrote all the words in the book, and Mark stood over me with a bullwhip saying, "Faster, boy, faster." Should be out soon. And he, oh, by the way, he wrote all the tools, so give him credit for that anyway. Let's see. I'm going to run Process Explorer as a local system. So this is psexec. -S says run this thing as system. I says run it interactively. D says don't wait for that process to exit before returning control back to the command prompt. And there is Process Explorer running as local system, as you can see up here. Let's do that. And let's add a couple columns, username and session. Drag those over. And now we should be able to see something here. Ah, yes. There's Notepad, and there's Calculator. That does not look like the icon for Notepad, nor the icon for Calculator, and Notepad does not normally run out of Toby's downloads folder. So this is running as Toby, a user named Toby, out of his downloads folder. But because I am running without the debug program's privilege as administrator, I can't see that. I cannot see the processes that are running on my box unless I pull some stunt to run something as local system. From here, though, as local system, let me prove that. So here's Process Explorer. This is the process we're running right now. And I am running with the debug privilege. So from here, I can kill Notepad, or whatever it is, and I can kill Calculator. So not really any security benefit there. Switch back. Okay. Next, turn off automatic root certificates update. Now, the guidance has been, and this is only federal government. Microsoft guidance has never included this. One of the things that's in the federal guidance has been take the Microsoft guidance and then add a bunch of stuff to turn off all the phone home capabilities. So anything that connects automatically to Microsoft.com, they turn that off. And for certain parts of the government, that's a really good idea because you can leak information when you're doing that. But for a lot of the federal government, like, I don't know, the FTC, not as important. The information there is not as sensitive, doesn't need to be protected as much. Anyway, this one is automatic root certificates update. Default is not configured, and it's equivalent to disabled. The guidance says turn it off. So let's talk about what this is. So in Windows, you have a bunch of trusted root certification authorities, CAs. Okay, there's a program that we run where we allow a bunch of different CAs from around the world to be included in Windows, so that when something is signed by a certificate that chains up to one of those, you automatically can trust it. You know that, assuming that the CA does things responsibly, which we're supposed to check, there's a chain of trust that you can rely on. And these trusted CAs are baked into Windows, and they can be updated through Windows Update. Starting in Windows Vista and continuing in Windows 7, what it meant to be in the box changed a bit. So the trusted root CAs store actually contains very few CAs or CA certificates by default, 8 or 9 when you first start up. The idea here is to improve performance. Every single time you need to verify a signature, all those certificates need to be loaded into memory so that you can verify, does this chain up to something we trust? Loading that stuff into memory pushes other things out of memory, spins the disk. We're looking hard at ways to save battery power, don't spin the disk if you don't have to. Don't use more CPU than you need to. Don't consume memory, etc. So we only put a small handful of CAs in there by default. But when you check a signature on something and it chains up and the certificate is not in there, we check to see, is it in the program anyway? And if it is, we add it to the root CA store automatically, even if you're offline. And the way we do that, it was really, we haven't published a KB or anything about this. So I found this mysterious behavior when I was testing stuff at a government customer and contacted the product group and found out, oh, yeah, that's what we're doing now. So if you're offline and you check one of these things and you don't have access to Windows Update, it'll go into crypt32.dll where we have as embedded as resources all the certificate trust lists and root certificates that were valid at the time the Windows 7 shipped. And if we find it in there, we pop it into the CA store. But that works only if automatic root certificates update is turned off. Or, I'm sorry, does not work if automatic root certificates update is turned off. So why they do this? To block the phone home. Don't release information about certificates that you might be looking at. It's never been part of Microsoft's security guidance because, well, frankly, we trust Microsoft. Go figure. Another reason why you might want to turn this off is to give you absolute control, you as the IT administrator, full control over what certificates you're going to trust. So in your environment, there may be a bunch of CAs out there you don't want to trust, and others that you do. The impact of this setting is, first of all, obviously there are many fewer default certificates in that store on a US GCB compliant system or FDCC compliant. And as a result, lots of files, lots of legitimate files, will be treated as unsigned. Because it says, if the root cert isn't in there now, we're not going to go get it. And if we can't verify a signature, we treat the thing as equivalent to not signed at all. This also applies to websites that have server certificates that chain up to a certificate that's not in the store. This is a screenshot I got. I went to Amazon.com on a system that had it configured this way and got the big, ugly warning. So what you need to do is manage your root CAs very carefully, or if you don't want to do that, turn off the setting. Good news again, USGCB no longer requires this because of this demo. So let's see what that looks like, because you won't believe me otherwise. Nobody trusts Microsoft. Okay, so here is Java. This is a bit older. Don't install this on your system. Well, don't install Java unless you absolutely have to. But if you do, by the way, make sure you've got the very, very latest. Java is now the most widely attacked piece of technology on the internet. It's very widely deployed, and attackers are exploiting it all the time. So make sure you've got the latest build. Do not let your developers say, we need to have this one specific build. Okay. Does anybody have Java developers who do that? Yeah. Tell them they need to get out of that habit.
But you have today's update.
Today's. The latest I saw was 25. Is there a new one? See, I don't install Java on my system, so I don't have that problem. Oh yeah, no, yeah, but there are vendors out there who, yeah, I know, it's a tough problem. Sometimes it's not under your control. The vendor will say, you need to run this specific build, but you need to push back and say, look, you're putting us at risk. Here's the list on, I think you get a cert.org or any of the other vulnerability sites, and say, here's what we're at risk of having happening. And there's links also you can look up our security guidance. The Security Intelligence Report has been describing these risks and these kinds of attacks. So anyway, this program is signed by Sun Microsystems, but if I look at the details, signature cannot be verified. So let me go into the group policy editor. The setting here is System Internet Communications Management, Internet Communications Settings. Turn off Automatic Root Certificates Update. Set that to not configured or disabled. Okay, close that. Properties. Now there will be a timeout here because it's first going to look for a network, and I don't rely on the network for my demos because if I rely on the network, then I have guaranteed failure. So I click there. Oh, by the way, when I started out, there were 9 certificates in here. And this is still spinning. But if I come in here and refresh, now there's 11. And this is the local machine store. So Windows, stuff running as local system in the background is handling this for you. Okay. So if you don't have that setting, the cert store will populate with the certificates that you need. And that was a huge mystery the first time I saw it. So hopefully that's some help. Another part of the security guidance, and I've never gotten this one, hide mechanisms to remove zone information. Attachment Manager, Attachment Execution Service tags files that you download to say this thing came from the internet. Continue to treat it as though it came from the internet until you say this one's okay, don't warn me anymore. There's a group policy setting which is recommended through all the security guidance out there to hide that from end users. So end users can't do that. I consider it misguidance, but they don't always listen to me. So have you ever seen this? You go to run a program and you get this dialog, right? Or perhaps worse, you open up a CHM file. Again, these are examples from sysinternals. Mark's help files are CHM files. You download from sysinternals.com, and you go to look at the online help. Have you ever run into this? Show of hands? Or actually applause. Let's hear applause, because that'll... Thank you. The reason for this, files from the internet, that security zone information, when you download it, gets tagged into the file as an alternate data stream. It doesn't modify the main file. It adds an alternate data stream. It's an NTFS feature. And it tells you what the Internet Explorer security zone is, and then the Windows shell will continue to treat the file as though it came from that zone. By default, users can remove that zone through that checkbox and through the unblock button. The security guidance hides those interfaces. So that checkbox gets hidden, and the unblock button gets hidden. So you don't have that. So instead, every time you run the program, you get the warning every single time. So why is this good? I'm sorry? It is easy to go around it. Well, I'll show you that in just a second. So one thing I really hate are security warnings that don't give you any information. And these security warnings don't tell you anything. They don't give the end user any information with which to base a security decision, assuming that end users should be making security decisions anyway. But how much security is really involved in this? Because it doesn't actually stop the user from running the program. If it's dangerous, don't let them run it. Duh. And it trains users to expect and to ignore warnings. If a dialog comes up, it ought to be something they ought to pay attention to. And if you flood them with useless stuff, they just click through it. How many of us click through warning messages all the time? Yeah. And you admit it too. Very good. So the one benefit that I can see here is, okay, if you get a malicious CHM file, this will block it from running. But how much of a threat is that really? So mechanisms that remain. There is another sysinternals utility called streams that will show you the alternate data streams on files. And with the -D option, allows you to remove those streams. So if you have write access to the file, you can remove the alternate data stream from the file, streams -D. What I always do is sysinternals suite, that's the full set of all the sysinternals tools, download that before I extract anything out. I remove the alternate data stream. Because if you don't, then when you extract it using Windows Explorer, the alternate data stream, the metadata, gets propagated to all the files you extract out of the file. So I unblock it first. Another thing you can do is just overwrite it from the command line. The syntax for alternate data streams is name of the file, colon, name of the stream. In this case, it would be procmon.chm colon zone.identifier. If you do more MORE angle bracket, like get standard input from that, it'll show you here's what's in there. And then you can overwrite it by echoing over it. And then if that information's not there, then it won't treat it as from the internet zone. Log off here. Okay. This will be a fun one. Okay, so I'm going to log in now. I was logged in as Abby. I'm going to log in as Toby. Toby's a standard user. Toby cannot do administrative things on his system. If Toby wants to run something with admin rights on his desktop, he needs to supply the username and password for an admin account. Now, some people will say, this is secure, right? Let's talk about the concept of security boundary first. Has anybody seen Mark Rusinovich's talk about security boundaries? So there's security features which help mitigate the chance that something will go wrong, but it's not a guarantee. And then there's security boundaries where we say, if anything crosses from this side to this side without going through an approved mechanism, that's a bug, that's a security bug, and it will be fixed with a security patch. Okay? Same desktop, UAC elevation is you're running something on a desktop, running a standard user, and you say, let me run something with full admin rights on the same desktop. There is always going to be some risk of elevation of privilege. Okay, it's just not possible to guarantee that that elevation will not be compromised somehow. So I'm logged in as Toby. I'm going to do some computer management. I'll go to computer, manage, and I get a prompt. Abby is an admin. And apparently I typed it wrong. Uh-oh. What happened here? So here's computer management. It is running with full admin rights. Can I get to stuff through here? Event viewer, Windows logs, security log. I have to be admin to get there. And this is working. It's not giving me access denied. So this elevation did work, but something came along for the ride. Note the secure password. So what happened here? That first prompt was not the real prompt. That first prompt was spoofed from malware. Malware saw elevation coming, prompt the user, grab that admin username and password. Now from there, what can the attacker do? They can't get admin rights. The best you can do, if you have username and password, and you do a simple logon user using the Win32 API or run as, is you get the lower half of that, the standard user version of that user account. But that's enough to put some stuff into Abby's account so that when Abby does run something, this other thing will come along for the ride. The problem here is in order to invoke the elevation, you have to go through software running as the standard user. And the standard user software can do a lot of stuff to capture that. And so that's what happened here. So what can you do about this to help mitigate this particular threat? One is don't rely on same user or don't rely on same desktop UAC elevation. Fast user switching, right, where I go to switch user, that involves a security boundary, right, because they're running in two separate terminal server sessions. If they're running in the same terminal services session, then there is a risk of some compromise because there's a lot of shared surface in there where they're both looking at the same objects. So the thing that makes this different from the past, let's talk about Control-Alt-Delete, what we call the secure attention sequence. When you press Control-Alt-Delete, that is captured by the operating system. Okay? No software running with standard user rights can do anything to intercept or interfere with anything when you press Control-Alt-Delete. You're guaranteed that when you press Control-Alt-Delete and control is transferred to the secure desktop, where you get the password prompt and all that kind of stuff, you're guaranteed that you're interacting with something running as local system. Now, if the system has been completely compromised, you know, it's not really Windows anymore, so it doesn't matter. But standard user software cannot get in the way of this thing. The number one reason for one of the top reasons for introducing that was to ensure that the user interface, the password prompt, could not be spoofed. This has been in Windows since NT 3.1, the first version of NT. And it ensures that these credentials cannot be intercepted. The thing that is a trick here is, starting in Windows Vista, we have this UAC elevation. You're going to the secure desktop without pressing Control-Alt-Delete. So how do you know you're really going to the secure desktop? How do you know it's not some program that is just doing a gray out of the screen and then popping up its own dialog? And the answer is you don't. So there is a setting called Require Trusted Path for Credential Entry. And by default, it's not configured, and so it doesn't come up. USGCB, the first versions of USGCB, they tried turning this on to help mitigate this threat. And I thought that was an interesting idea, but I knew it wouldn't fly. And why is that? What happens is the graphical user interface, the entry, CRED UI, that prompts for credentials, will, anytime you invoke that, it will require Control-Alt-Delete. This happens for UAC elevation. It happens if you enter credentials through a remote desktop client. You have to hit Control-Alt-Delete to enter the username and password. And in Windows 7, if you map a network drive with different user credentials, you need to enter Control-Alt-Delete again. So is it more secure? Well, it prevents some types of credential prompt spoofing and stealing if you happen to notice that you're being prompted before you hit Control-Alt-Delete. before you actually enter the credentials. Does anybody want to see a demo of it and see what it looks like? Has anyone seen this before? Okay. Let me show you what it looks like. So we're back here on the desktop, and as long as I have a command prompt with full admin rights, I'll go ahead and use that. GP edit. This one is under Administrative Templates, Windows Components, Credential User Interface, Require Trusted Path. Let's enable that. Okay, so now let me bring up something that's not going to bring up the spoofed UI. So let's say I'm going to elevate calculator. I didn't hook that particular path. Run as administrator, I get this. Okay, if I want to continue, I click this. Then I press Control-Alt-Delete. Then I enter my username. Now I just hit Control-Alt-Delete. This UAC prompt is being presented by something running as local system. That's a guarantee because I press Control-Alt-Delete. And I'm not actually going to run that, but I can run something with admin rights. But those are the additional steps you get. So let me set up the malware demo again real quick here. And see if it would make a difference. Okay, so then I go to right-click, Computer Management. Okay, go ahead and enter username and password. And then I get prompted, oh, you have to press Control-Delete first. Too late. All right, so it helps you, like I said, only if you happen to notice before you enter the credentials that you didn't hit Control-Alt-Delete first. Is that gonna, how many times is that going to save people? So is it worth it? Federal government finally decided, no, we're not going to live with this. Obviously, it requires a lot more steps. Your users will hate you, and they will let you know it. Another thing about it also is that it also applies to same user elevation. So there's different types of elevation. If you are a member of the administrators group, everything runs as standard user until you go through an elevation prompt, which is a simple yes, no. Preferably on the secure desktop. Why do you want it on the secure desktop? To make sure that something running as standard user can't interfere with that somehow. But if malware spoofs that dialog, what can they get? Nothing. They can't actually gain admin rights by spoofing a simple yes, no. Spoofing a credential dialog, there's some value in that. But this setting was driving people crazy because even for simple yes, no, they had to go through 3 or 4 different steps. So that got turned off completely. Another one of the security settings that's, I think it was taken out. Do not process the legacy run list. Has anybody ever applied this? Do you like it? No, nobody likes it. This setting, and by default it's not configured, you have in the registry HKey local machine, software, Microsoft, Windows, current version, run. And within there you have a bunch of values that list things you ought to run every time anybody logs onto the system, right? It's a very common auto start entry point, which you can view with auto runs, another sysinternals utility. And it lists command lines that will be executed by Windows Explorer at the time the user logs on, and it runs with the rights of the logged on user. Oh, by the way, there's 2 keys on a 64-bit version of Windows because there's, for some reason, there's 2 of them. So obviously, legitimate programs use this, but malware uses it a lot too. What does malware want to do when it gets on your system? It wants to make sure it stays there for a while. It wants to run every time you boot up your system, and the run key is one of the easiest ones to compromise. And so malware's been abusing it for years and years. And so a lot of security guidance says, you know, must turn that off. The thing about this one is it's under HKey local machine. You have to be admin in order to modify this setting. You know, if your users are running with admin rights, you've got bigger. How many of you have your users running with standard user rights? And how many of you let them just do whatever they want on the machine? How many of you are responsible for the systems that users can do whatever they want on the boxes? Does that make you happy? No. There is a per user counterpart under user configuration. The current user run key, which is set on a per user basis. And for some reason, I've never seen security guidance that says disable that. Even though more and more malware now is starting to run with standard user rights and run correctly as standard user and dropping stuff in the user's settings instead of the machine settings. So are there benefits to this setting? On well-managed systems, there is, I would argue, no benefit at all. Well-managed systems meaning users don't have admin rights. Because in order to exploit this, they need to have gotten admin rights first. Once you've given up admin rights, there's nothing you can do. And the thing is that an attacker who gains admin rights, there's tons of other stuff they can do, tons of other places they can hook the system and gain permanent control over it without touching the run key at all. So what kind of stuff is there? I knew I shouldn't have let them. It's the last time I'm letting Silver Fox touch my deck. Should be a little more visible. So lots of legitimate software uses that setting, right? You've got stuff from the OEM to enable features so that it can interact with features that are exposed through the OEM's hardware. Adobe has this very helpful program which runs all the time so that when you bring up Adobe Reader, it seems to come up quickly to hide the fact that apparently they have performance issues. Using auto runs, you can disable that by unchecking the checkbox. That requires admin rights, but you're the admin. What else would be in there? Antivirus stuff will often run from there. SCCM agents, enterprise desktop management agents, Altiris and stuff like that will typically get started on the system from here. So if you disable that setting and you don't allow the stuff to run, that stuff doesn't run. They don't have an interface to the antivirus that's as easy to get to. They don't have SCCM or Altiris, those client components there. So I consider it misguidance to set that one. How many of you have run into this setting before? Do you like it? No. So this one kind of comes and goes. The idea here is NTFS. Back in the DOS days and the 16-bit Windows days, the FAT file system allowed you to have a file name that was up to 8 characters, no spaces, dot, and up to 3 letters extension, right? For backward compatibility, when Windows NT introduced long file names, they automatically, whenever you create a file that doesn't fit into that 8.3 specification or has spaces in it, it automatically creates a 8.3 compatible version of that. And you've probably seen this. So if I go to here, /x shows you the long names and the short names. So these are the 8.3s, they, ~1, etc. So there's been security guidance, which always mystifies me, that says you should turn this off. You should turn this feature off. And the guidance further says that the only reason you might not want to turn it off is if you happen to still be running any 16-bit software. How many of you knowingly run 16-bit software? And the rest of you don't know that you're actually still running 16-bit software. There's a lot of it out there. Old installation programs will use 16-bit components because back in the 90s, when InstallShield and others were writing their stuff, they would need a single installation program that would work correctly on Intel hardware, on MIPS, DEC Alpha, all these different platforms, and they'd want to install a different program. And the only way they could run something that would work on all of them was to use 16-bit, because the NTVDM, NT Virtual DOS machine, could run any 16-bit program on MIPS, DEC, whatever. To this day, we still have, I bet people haven't seen this one. Check this out. This is 32-bit Windows 7, sysedit. Oh, please run. There it is. autoexec.bat, config.sys. How many of you ever use sysedit.exe for management? Check the icon. I love this. Wait, I need to zoom in here. You see that? Recognize it? The old program manager. So this is 16-bit software that still ships in 32-bit Windows today. If you need to do your system configuration, this actually is a whole lot easier to use than group policy. So I would, yeah, you can skip Jeremy Moskowitz's session later and just learn all about sysedit. So anyway, where was I? Getting a little off track here. So the thing is, yeah, there's still 16-bit software out there, but that's not really the big problem. The problem is a lot of other things also depend on short file names. Like batch files, like people will sometimes specify short file paths so they don't have to worry about putting quotes and handling the spaces. And I've been told that SCCM does not work on a system where 8.3 has been turned off. By the way, if you turn the setting on, it only applies to new files that are being created. Any files that were already created that have 8.3 names will still have them until you rename them or something like that. So the way I got them to get rid of this setting from the security guidance was to read them their own vulnerability information, the threats and countermeasures for NTFS disable 8.3 name creation. Clearly, the bulk of attackers we're really worried about can't type. If we make them type 20 characters, we win. Attackers could use short file names to access data files and applications with long file names that would normally be difficult to locate. An attacker who has gained access to the file system could access data or execute applications. If they have access to the file system, they can already do that. Short file names doesn't, turning off short file names doesn't prevent that. So that's been removed, I'm glad to say. Some blog posts for further research that you might like. Security guidance, configuration guidance support, KB 885409, one of two articles I've memorized the number. This is the one that basically says, don't mess with the default security settings, the permissions on the system. They're good. And everyone's on board with that. Another one I wrote recently, sticking with well-known and proven solutions. This one I wrote because I ran into a lot of customers where they painted themselves into a corner by customizing their environment so much that it was really hard to move forward. They had problems that nobody else in the world has because they would go through security settings and say, this one looks good and this one looks good, and they'd end up with side effects. One of my customers, let's see, they applied an IE security setting that prevented encrypted content in Internet Explorer from being saved to the hard drive. Well, that sounds like a good idea. If it's encrypted, don't save it to the hard drive where it could be exposed. That's good. Payday comes, union shop, and people go to check out their pay stubs, and they can't because the PDFs are not being saved to the hard drive where they can be viewed. That became a huge problem. And because they were using a security setting that we hadn't messed with before, it took us a long time to figure out exactly what the policy was that was causing that problem. And on a Friday, not a happy time. So sticking with well-known, well-proven security guidance, prescriptive guidance that lots of other people are using is going to be a better bet for you. Another thing also is don't use homegrown application deployment software, because go with something that's proven and a proven enterprise solution. Another one here, this one I think a few people might find interesting. How many of you manage servers? By applause, because I can't see over the lights. Yeah. Thank you. This is a blog post I wrote a few months ago, and it's finally official Microsoft policy now. Our assertion, KB 2526083, just got published within the last hour or two, which basically says user account control may not be appropriate for the server. If it's a well-managed server, right, where you're not browsing the web, the only reason you're ever logging on is to administer the server, UAC prompts are not going to benefit you at all. You're welcome. I've been fighting this one for a long time, but it's finally up. So this doesn't mean turn off UAC everywhere. This applies only to server, and only if it's well managed. If you have end users logging on through terminal services or something like that, there's some other features of UAC you'd like to keep enabled. Okay, Internet Explorer protected mode is disabled if you turn off user account control. So protected mode is a good thing to have. Don't be browsing the web from your domain controller. Okay, and then it's okay to turn off UAC. Do read the full article before you apply the policy, though, or disable the policy. Turns out that FDCC still included some file permission settings, which were also in our security guidance until fairly recently. And it turns out that some of those file permission changes were not good. Instead of sweeping through the entire file system, we said it's okay on XP to turn off or to make it so that you have to be admin to run regedit and regserve32 and a few others. And it turns out regserve32 is used by standard users the first time you log onto a system to register some per-user components, and a bunch of stuff doesn't work properly if end users can't run regserve32 the first time they log onto a system. And there's also a blog post I wrote. You should be able to download the deck from the network here, but there's one where I showed a custom security setting that was actually getting pretty popular in the DoD that caused all kinds of other things to break. They were trying to turn off auto run for USB, and instead they broke installation programs for scanners and printers. Security Compliance Manager is something you really need to look into. Links to SCM webcasts and demos. If you want to manage local group policy, I've written some tools that can make that a whole lot simpler so you can automate those processes instead of having to do them manually one at a time. There's a webcast from TechEd in Europe last November where I demo a lot of those tools also. Related content. SIM 305 and WSV 325. Yeah, WSV 325 is going to be the main one all about Security Compliance Manager. If you're interested in managing security policy, I strongly recommend you go to that. These other sessions will be interesting as well. And they added some other slides to my deck, which is good. Here, you can look at those. I always like it when they add stuff to my deck. I really like it when they screw up my formatting. Other resources. Complete an evaluation on ComNet and enter to win. Now, please do fill out an evaluation. If you like the content, the scale goes from 1 to 5. The more 5s you put in there, the better your chances of winning. If there's anything you didn't like, you don't need to fill out an eval. You can just come talk to me personally. And there's stuff you can do with these mobile devices. And there's our logo. All praise be due to it. Okay. If there are any questions, we've got some time left. I've got, for good questions, I've got T-shirts to give out. So any good questions about security policy or anything, please go to a microphone so it can be on the recording and I don't have to repeat the question. So there's microphones around the room.
Yeah.
Hello.
The question is, if there's no good reason for disable 8.3 name generation, why is it a policy setting option?
Oh, why is the policy what?
Why did Microsoft configure it as a policy setting option?
Okay, so are there, basically, why do we put anything in there that might not be a good idea?
Right.
Which is a fair question. Now, when I say that there's no good security reason for it, I stand by that. However, there may be other reasons why you might want to do that. For performance, for one thing. If you don't have to deal with two file names on a high-performance file system where you don't have to worry about, where you know exactly what software is going to run, you may want to turn that off for performance reasons. So there is that benefit. But yeah, the thing is, Windows has evolved over a long period of time. And there's a lot of stuff in there that seemed like a good idea at the time that turns out not to be such a good idea. Why do we have power users in the system? Power users is basically administrators. Why do we want to propagate that fiction? Well, we figured out after a while it didn't work, and so we've basically stripped it out. On Windows Vista and newer, power users has very little additional capability. It doesn't have the power it used to have. But some of the stuff is just live and learn and try to improve the product over time.
You talked about the Control-Alt-Delete standard user interception, and I was wondering if you could use remapKey.exe to remap one of those to something else so that you could intercept the Control-Alt-Delete.
Okay, so first of all, I want to, the person who asked the question over there about why do we put stupid stuff in Windows, do you like large or extra large?
XL.
What's that?
XL.
XL. Okay. And there's a fitting room, and Chris, the track owner in the back, can talk to you about meeting up with a tailor to get it fitted perfectly. Thank you. So the question was, can they remap the Control-Alt-Delete key?
Yeah, so Microsoft had that little utility to remap a key on a keyboard to be something other than what it says, and it's called remapKey.exe, and so it's
Does
common.
that require admin rights?
That I don't remember.
I don't think you can remap the keyboard without admin rights. If it requires admin rights, then it's not a security vulnerability.
Yeah,
Does anybody know?
I'm going to test it anyway, but
the comment is the secure attention sequence goes through the BIOS. I think it's not the BIOS per se, it's at the driver level though that they capture that. So it's a very low level that standard user software can't intercept it. But the thing is, you can say, I don't want this to be the control key, I want this other thing to be the control key. But as far as I know, that requires admin rights. And so you're already on the other side of the security boundary at that point. Okay, so the comment is he doesn't think you can remap the Alt key. That may be as well. Yeah. Okay. You still need to press 3 keys, but yeah. Gaming keyboards, yeah, but it still requires admin rights. I'm going to take a question from the microphone so I don't have to repeat the questions.
Aaron, the security guidance for Exchange 2007.
Sorry, speak closer to the mic.
The security guidance on Exchange 2007, I don't know if it was ever finished. And do you know anything about the status on the security guidance for Exchange 2010? Do you develop it in parallel or do you develop it afterwards?
I would go to the Security Compliance Manager session because that guy knows. Jeff Sigmund will know everything about that.
Okay, thank you.
Microphone.
What's your perspective on managing ActiveX and trusted sites lockdown?
Do you want large or extra large? That's a good one.
Large.
Large. Okay. ActiveX controls. ActiveX seemed like a good idea at the time, right? And it's still widely used, and there's still good places for it. There's things. The thing about ActiveX is it's more than just web technology, and ActiveX can be reused in a lot of great ways on the desktop. Through the browser, the thing about ActiveX that made it really compelling was there was this browser-based delivery model that required admin rights, and when everyone was running Windows 95, that didn't seem like a big problem. If you have a continued dependence on ActiveX controls in your environment, the best solution, if it's a well-managed environment, is the ActiveX installer service. Are you familiar with that? Okay, so what the ActiveX installer service gives you is a way through group policy where you can say end users who don't have admin rights are allowed to install ActiveX controls from this site, and this site, and no others. And so you can control which ones they can install. When they go to one of those sites, the ActiveX installer service checks and sees, is this something that is configured through group policy? If so, the user just gets the normal prompts that they would have gotten before UAC, with admin rights. But the service, the ActiveX installer service, actually performs the actions that require admin rights. And so that's a great way to, to deploy ActiveX controls if you're still using that model. That's the best way. There's other ways to do it that are not quite as elegant, but basically you need to take the ActiveXs and deploy them through some other mechanism. Oh, and there is one other that I haven't seen used yet. Windows 7 and Internet Explorer 8 and above give you the ability to have per user ActiveX controls where you repackage the ActiveX. User goes to install it, it installs only for that user. It doesn't register machine-wide, it only installs for that user. And so that can be another option as well. Over here on the left, on my left.
I just wanted to get some clarification when you were talking about UAC not being a security boundary.
Mm-hmm.
We've been in the process of trying to train some of our desk side support people to do run as when they need to do admin work as opposed to logging in.
Sorry, can you a little closer to the mic?
We've been trying to convince our desk side support person to run as when they need to run group policy editor or some tool like that, computer management. Should I really start to get them more into the mode of running 2 sessions?
So run as, the thing about run as is beginning with Windows Vista, when we introduced user account control and the concept of single user with both standard user rights and admin rights, and going through the elevation prompt, the quote secure elevation prompt on the secure desktop to use something with admin rights, run as will no longer give you that. So if you do run as name of executable, then you only get the standard user version of that user account. And so if you're doing administration, run as won't really help you. One exception, and I hate to see customers do this because it's kind of a glaring hole, if you've enabled the built-in administrator account, the original -500 built-in admin account, there's a UAC setting where you can say UAC doesn't apply to that one. Anything it runs always runs with admin. And I've seen customers use runas.exe with the built-in admin account, and that will run something with full admin rights. But that's fully scriptable at that point. So I'm not crazy about that idea. Now, the idea here, the one thing I do want to point out, the risk you've got with same user or same desktop elevation, the reason for pointing this out isn't to say if you do this, you will get hacked. Because today that's generally not true. I've seen malware running with standard user rights. I've seen malware attack Windows 7 computers, but only use standard user rights. They haven't, the ones I've seen, haven't yet bothered to try to get around UAC. When they do, there's 2 ways they may want to go. If you're running with admin rights, what we call protected administrator, where you run everything as standard user, and then there's the same user elevation paths, that's going to be fairly easy to attack once they start paying attention to it. What I showed you is that even if you use a different account for administration, same desktop elevation does have some risk associated with it. When will that become a significant risk? Depends on the business you're in. If you're faced with certain well-funded bad guys, let's just say, or maybe you are a bad guy, I don't know. then there may be significant risk if there is a targeted attack, right? In the meantime, probably pretty safe. But if you want to stick with security boundaries, fast user switching is really the only thing you've got. And so what I would do is switch to a completely different. This is the way I manage my daughter's machine. I don't do same user elevation on her desktop. I switch over to an admin account that she doesn't have the password to. Question?
Just a thought, not a question, about UAC. There are quite a lot of keyloggers out there who can capture your credentials when you enter them in the UAC prompt. And you can run them as a normal user, and you can't even see a taskbar icon. You can only see them in Task Manager, and you can pop up them with some hotkey. And there are quite a few of them out there. And I have seen them on user workstations running. And you can only spot them really in Task Manager. And you should always check before you run anything in standard user and put your credentials in. Unless you are on secure desktop.
And you're saying it's spoofing the UAC prompt?
No, not spoofing, just capturing credentials at UAC prompt. When you're entering credentials at UAC prompt, if you are not on secure desktop, you can capture credentials.
Well, there's supposed to be other protections that prevent that from happening.
Only if you are on secure desktop.
Well, there's the secure desktop. There's also user interface privilege isolation.
Okay.
Oh, wait, you know what? Well, there's the one that says, yeah, they go to a different desktop, but there's also user interface privilege isolation, which is a feature of UAC, or is dependent on UAC, where things running at a higher privilege level cannot have certain window messages sent to it, right? So if you've got something running as admin on your desktop, something running as standard user shouldn't be able to programmatically send keystrokes to it, right? Or to send window messages to it. So I'd be interested to see that. I mean, I don't doubt that there's a way to do it, but I kind of doubt there's a way to do it. Kind of. But I'm not going to say there isn't, because it's not a security boundary. On this side, thank you.
Okay, first of all, I work for the government, so I thank you for all the stupid settings you got NIST to get rid of. Those are less things.
Sorry, I can.
Okay. I work for the federal government, so I thank you for all the settings you got NIST to get rid of that we don't have to deviate from anymore.
What part of the federal government?
U.S. Geological Survey, DOI.
Okay.
So I have two more. So if they're talking with you, these would be great ones.
There's my pen.
In an environment where we have least user access, there's a setting that's asking us to manage browser helper objects and lock those down. So it seems like if a user cannot install their own software and install browser helper objects, and we're making that, as an administrator, that decision, why would we have to then also shut off browser helper objects for them? So that's kind of annoying. And also, cached credentials, for some reason, even though Microsoft's always recommended 10, FDCC and USGCB have always put us back down to 2, which is not functional. So,
yeah.
Do you have any reasoning behind those 2 settings?
I'm in a good position where I don't need to defend any of those decisions. The browser, okay, so there's a setting, a group policy setting where you can say disable all third-party browser extensions, and that includes, when we say third-party, that means anything that's not part of Internet Explorer itself. So that includes MSN, it includes any Adobe add-in, anything like that. So all that stuff gets disabled. And the idea there is, browser helper objects and toolbars are commonly used by malware, right? So spyware installs as a toolbar, as a browser helper object, things like that. But as you correctly point out, standard users can't get those things installed to begin with. In the meantime, there's other browser extensions like Adobe's add-in and other add-ins like that just don't work. So I've been pushing them actually to adopt a different setting which allows a whitelisting, where you can say they're disabled unless they're on this list.
Well, that's a good idea, but for us to manage our own browser helper object server.
Oh, so wait, you're talking about like the ability to enable or disable individual ones that are already installed?
No, what
Nope.
I'm talking about is it seemed like the guidance on how to get around the setting in general was that we could set up our own browser helper objects, sort of like internal management server, and approve or disapprove certain objects. And then if they were on the approved list, just like anything else controlled from a central point, then users could have the ability to run those. But that's an enormous amount of maintenance for large
Yeah, I want
enterprises.
to dig into this more. Can we talk afterwards?
Yeah, sorry.
Okay. Next.
I think it's you.
Go ahead.
Obviously.
Oh, by
one
the
of
way, do you want large or extra large?
Certainly one of the original purposes behind the removal of the administrators from the debug privilege access is the pass-to-hash LSAS extraction attacks. Obviously, if someone is able to compromise a member server in the network, and you have domain admins that log on to member servers occasionally, which of course never happens, is there any way to protect against the pass-the-hash attack, that LSAS extraction, other than, and as you demonstrated, that debug right, removing it doesn't actually protect against that. So are there any other recommendations you would have to help protect against the pass-the-hash issue?
I know there's people who spend a lot of time thinking about pass the hash and that kind of specific thing. My basic thing here, though, is if they've got admin rights to begin with, they can do anything that comes through the box, they have access to. With one exception, encryption is not something that an admin can necessarily get around as long as it's not decrypted on that machine. If it's decrypted on the machine at any point, then the admin of the box can get that too.
I think probably the biggest concern that I've seen as a consultant with different customers is that obviously you have to control the different levels and layers of administrators. Domain admins should probably only be logging on to domain controllers, but that's not always feasible. So I guess right now what I'm struggling with is trying to provide security recommendations specifically to protect against issues where you may have a member server that's been compromised. You may not know it's been compromised for a number of time or a period of time, in which case other admins could log on to it. Those hashes could be gathered and then passed on, injected into LSAS to then elevate or escalate to a domain controller or another higher security component or server on the network. So that's a big concern I have. I know there's other people that have that concern. Obviously, there's no good answer today, but I was wondering if you had heard anything or know anyone.
That's one where I'll have to say that's out of my area. That's past the hashes gets into some dark arts that I haven't really gotten into. Except I would think that the fact that you don't have delegation enabled might have something to do with it. But again, I don't really understand the full risk of pass the hash, how it works, and things like that. Apologies. Question over here.
You were talking earlier about whitelisting. Could you expand on that?
I was answering a question relating to third-party browser extensions, toolbars, and ActiveX controls. There's a group policy setting that's currently part of USGCB that says disable all third-party browser extensions. There's another setting where you can say, where you specify the GUID of the extensions you want to allow. So instead of saying no to all of them, you say no to all of them except for a specific list of approved ones. And there's a group policy setting for that.
Oh, okay.
Okay. Did I run over yet?
No.
Okay. Close to, right? Light has turned red. Thank you very much, those of you who are still here. Thank you very much for coming. Look forward to seeing you around the Tech Ed here.